A particle of mass 3 kilograms moves in a straight line on a rough horizontal surface. The coefficient of friction between the particle and the surface is 6/49. Find the frictional force and show that the deceleration of the particle is 1.2 meters per second. The speed of the particle at the point O is 9 meters per second, and it comes to rest at a point A. Calculate the distance OA. So here's the question in summary form then, with all the information contained. And so let's have a look at the diagram. It's moving forwards. We know that it has a mass of 3, this particle, so the weight will be 3g. There's no forward force acting on the particle, but there is a frictional force. The reaction vertically we can label as R, and we know that mu r is the frictional force. So it's 6/49 times R. So it's moving on a horizontal surface. So A, let's have a look at this then. Find the frictional force, so we need to find this value here. So we can label this as F equals mu r, can't we? Okay, so vertically then, we'll apply F equals ma then, in the vertical direction. That gives, so we got r minus 3g, and there's no acceleration, so that equals 0, so that tells us then that r is equal to 3g. So there's r. Okay, so that's that one. Now if we apply F equals ma in the, well, it's going forwards. I'm going to put it going forwards here with the acceleration a. So we're going to apply F equals ma in the forwards direction then. So let's have a look at this. So we've got r minus F, which is mu r, isn't it? So r is the forwards force minus mu r, 6/49, times the value of r, which is 3g. Oh, that's the upward force. There's no forwards force, sorry. I misread the picture there and didn't think about the question. So we've got no actual forwards force. We've got a backwards force minus mu r is equal to the mass, which is 3, times the acceleration, which we've labelled in the picture as a. So here that tells us what the acceleration going forwards is then. A will equal, we can cancel by 3 both sides, so it's minus 6g/49. So let's tap that in the calculator then. 6 times 9.8 divided by 49 equals 6/5, which is 1.2, ms minus 2. So it's minus 1.2 ms minus 2 backwards, which is what we've shown in the reverse direction. So there's A then. So this would now, this is a minus here, so this is a plus, isn't it? So we'll get it right in a minute. So that's the deceleration. The speed at O is 9, and it comes to rest at A. Find the distance OA. So part B, we know the acceleration is equal to minus 1.2. We know the initial speed at O is 9. We know the final speed at A is 0. We want the distance, so what springs to mind is the equation of motion, v squared equals u squared plus 2as. Because we know v, we know u, and we know a, we can find s, the unknown. So v squared then, which is 0, is equal to u squared, which is 9 9s are 81, plus 2 times the acceleration. Well, minus 1.2 times 2 is minus 2.4 times the distance s. So that tells us what s is then. Move this over through the equals, so it's 2.4s is equal to 81, and s then is equal to 81 over 2.4. So let's tap that in the calculator. 81 divided by 2.4 equals 33.75 meters. That equals to the distance OA.